Hello guys, it's your favorite tutor again, as the Making Checking Wisdom. You are welcome to this session of our lesson. So on today we are going to be looking at the discounted payback period. Remember the last lesson we were talking about investment appraisals, and we said there are two types of techniques that companies use to appraise their projects. We have the discounted techniques and the non-discounted techniques. In our last lesson we looked at the simple payback period, which fell under the non-discounted technique. So on today's lesson we are going to be looking at a discounted technique, the discounted payback period, that takes into consideration the time value of money. So now, using our previous example in our first lesson, let's look at how we can calculate the discounted payback period, and we look at the project that we are going to choose. Now, moving to the discounted payback period, the question goes thus: a business is comparing two alternative investment projects. Project 1, an investment in new machinery, cost 90,000 francs, or Project 2, the purpose of a retail outlet. The purchase of a retail outlet at a cost of 90,000 francs with a discount rate of 10%. The expected net cash flow for each are: year 1, for project 1, you have 20,000 francs, year 2, 30,000 francs, year 3, 40,000 francs, year 4, 20,000 francs, year 5, 20,000 francs for project 2, year 1, 10,000 francs, year 2, 20,000 francs, year 3, 40,000 francs, year 4, 60,000 francs, year 5, 50,000 francs. And the second question is, using the discounted payback period, decide which project should be chosen. So now, to calculate the discounted payback period, we have to introduce what we call the discount factor. Now, the discount factor is 1 plus r to the power negative n, where the df stands for discount factor, the r stands for the discount rate, and the n stands for the year. Now let's introduce a new column. Now the discount factor column. Now to calculate the discount factor, we have for year 1 we have to take 1 plus 0.1, which is 10 divided by 100, the 10% that was given in the equation. 10 divided by 100 will give us 0.1. So we substitute it in our discount factor formula, which is 1 plus 0.1 to the power negative n. Now the n there is years, so for year 1 will be negative 1 to the power negative 1, which will give us 0.9091. We'll do the same for year 2. 1 plus 0.1 to the power negative 2. Now it is changing to 2 now because we are in year 2, so the year changes to from year 1 to year 2, which gives us 0.8264. Now we are running up to 4 decimal place. We'll do the same for year 3, we'll do the same for year 4, and we do the same for year 5. Now let's introduce another column, which is the discounted cash flow. Now to get the discounted cash flow, you have to multiply the cash flow of the project by the discount factor, which means if you look on the table, we have denoted the cash flow as A and the discount factor as B, so which is 20,000 francs times 0.9091, which will give us 118,182. Now we go to the next one. We take 30,000 multiplied by 0.8264, give us that amount. We'll do the same for the third, do the same for the fourth, and we do the same for the fifth. Now let's introduce another column, which is the cumulative discount factor. So now, like in our last lesson, we cumulated the cash flow in order to calculate the payback period, the simple payback period. So in this case, we have calculated the discounted cash flow, and we, in this table, this column, we are going to be cumulating this discounted cash flow. So the first one remains constant. The second one is, which is the first discounted cash flow plus the first cumulative discounted cash flow plus the second discounted cash flow. Now if you don't understand this step of accumulation, you can go ahead and watch our last lesson. We explain the process of accumulation very properly. So if you don't understand this process, you can go ahead, watch our last video, and then you are going to understand it. So we'll do the same for the third, the same for the fifth, and the same for the sixth. So now introducing our formula, which is A plus B minus C divided by D. Now this formula was explained in our last lesson. So if you don't know where this formula is from, go ahead, go to our last lesson, rewatch it, and then you're going to understand the formula there very well. Where A stands for the year before full recovery, as you can see, is denoted on the table. The year before full recovery, it's year 4, because our initial capital was 90,000 francs. So we're going to realize our 90,000 francs after year 4. So that's the year before full recovery. Our B is the initial capital, which is 90,000 francs. Our C is the accumulated discounted cash flow. You can see the accumulated discounted cash flow is 86,684, which form for year 4. Our discounted cash flow of year after A. The year after A, remember the A was a year before full recovery, so it means the A was 4, the year after A will be 5. So the discounted cash for the year after A will be 12,418. So now let's go ahead and substitute our formula, which is 4 plus 90,000 minus 86,684 divided by 12,418, which will give us 0.27. Now to convert this 0.27 to months, we're going to multiply by 12, which is 0.27 times 12 will give us 3.24 months. Now to convert this 0.24 to days, we are going to go ahead and multiply by 30. 0.24 times 30 will give us 7 days. So this means the payback period for project 1, the discounted payback period for project 1 is 4 years, 3 months and 7 days. It means that if we invest in this project, it's going to take us 4 years, 3 months and 7 days to realize our initial capital. Now let's move forward to project 2. Now just pause the video, go ahead, calculate the project 2, make sure that it is as we discussed earlier. Make sure you follow all the steps. It is the same procedure, just use project 2 and calculate. Now if you calculated project 2 correctly, this is your figures. Your discount factor should be that, your discounted cash flow should be that, and your cumulative discounted cash flow should be that. Now in substitute your formula, you're going to have 0.86, you multiply by 12 to convert it to months, you're going to have 10.32 months. You multiply the 0.32 by 30 to convert it to days, give us 9 days. So your overall discounted payback period for project 2 will be 3 years, 10 months and 9 days. So this means if we invest in project 2, it's going to take us 3 years, 10 months and 9 days to realize our initial capital. Now let's move forward to deciding which project we are going to choose using the discounted payback period. Now our decision rule, now it took us 4 years, 3 months and 7 days for us to realize our initial capital in project 1, and for project 2 it will take us 3 years, 10 months and 9 days to realize our initial capital. Now we are going to go ahead and choose the project with smaller payback periods, because we are looking for something that we are going to realize our capital faster. So with this discounted payback period, we are going to go ahead and choose project 2, because of project 2. Now we are choosing project 2 because it has a shorter time frame, which is 3 years, 10 months and 9 days for us to recover our initial capital of 90,000 francs, unlike project 1, which will take us 4 years, 3 months and 7 days to realize our initial capital. Now linking this to our first lesson, we are going to realize that in our first lesson we did the simple payback period, which we selected project 1 as the project we are going to venture into, but using the discounted payback period, we are taking project 2 as the project we are going to venture into. Now it is because the discounted payback period takes into account the time value of money, we are going to consider the discounted payback period as our main technique for calculating the payback period. So overall, comparing the discounted payback period and the simple payback period, we are going to say the discounted payback period is more accurate. So MB, overall, using the payback period technique, we choose project 2. This is because the discounted payback period takes into account the time value of money, unlike the simple payback period technique which does not. So thank you guys for watching. I'm hoping to see you guys in our next lesson. I'm your favorite tutor Azimeke Champion Wisdom. So in our next lesson, we are going to be looking at the net present value. We are going to see how we can use the net present value to evaluate and appraise our project. So see you guys in our next lesson.